warm welcome to our respected resource persons, distinguished faculty members, and dear participants. I am delighted to welcome you all to the session 5 of this faculty development program as we continue this enriching journey of learning, innovation, and academic excellence. Before we proceed further, let us briefly reflect on the key insights from session 3 and 4, which have provided a strong technical and conceptual foundation for today's discussion. In the session 3 on the topic Different Energy Storage System for Electric Vehicles was handled by Dr. N.P. Subramaniam, Associate Professor, Department of Electrical and Electronics Engineering, Puducherry Technological University, Puducherry. This session provided comprehensive insights into various energy storage technologies such as lithium-ion batteries, solid-state batteries, supercapacitors, and hybrid energy storage systems. The key takeaways included understanding the trade-off between energy density and power density, the critical role of battery management systems, life cycle and safety considerations, and emerging trends in advanced and sustainable energy storage solutions for electric vehicles. In the session 4 on the topic Fast Charging of Electric Vehicles was delivered by Dr. M.R. Rajmi, Professor, Department of Electrical and Electronics Engineering, Amartya School of Engineering, Bengaluru, Amartya Vishwa Vidyapeetham. The session highlighted the growing importance of fast charging technologies in accelerating EV adoption. Key takeaways included an understanding of DC fast charging methods, charging standards, power electronics, converter topologies, thermal management for battery safety, and the challenges related to grid integration and infrastructure readiness, opening avenues for further research and innovation. At this moment, I kindly invite Dr. G. Murali Sir, Associate Professor EEE, to introduce our distinguished guest for this session.
Good morning. It's my pleasure to introduce our distinguished guest, Dr. S. Sendil Kumar. He completed his BE from Tyagaraja College of Engineering, MTech from Pondicherry Engineering College, and a PhD from National Institute of Technology, Delhi. And he started his teaching career from Ballam College of Engineering, followed by that from Rajiv Gandhi College of Engineering and Technology, and in Valim Engineering College. After that, he joined the National Institute of Technology, Trichy, in 2006. Right now, he is the professor in EEE department. So his area of interest includes EV, solar energy technology, he is also right now currently working as a project coordinator for various sponsor research projects from DST and ISRO Bangalore, and he is also the Associate Dean Electrical from March 2018 to January 2020. He is also the PEQIP Nodal Officer from March 2018 to January 2019. He is also various memberships in Indian Society for Technical Education, member of Institute of Engineers, and he is also the Board of Study members for various technical institutes. And right now he is guiding 10 PhD scholars. Thank you.
Thank you, sir, for that clear and informative introduction of our distinguished guest. Now, it is my pleasure to invite Dr. S. Sendil Kumar to kindly take over the session and enlighten us with his valuable insights.
Very good morning to all of you. Actually, today I am going to handle the session related to the overall information about the electric vehicle systems. So I asked to handle AI based battery management systems. So whatever the work carried out by the students at NIT Trichy under my guidance, I brought in some case studies. I have updated little slide this way. Okay, fine. So earlier the speakers, many they talked about the electric vehicle systems, correct? So why we are going for electric vehicle? Again, I am asking the fundamental questions. Started. Yes, pollution. Very good. Then most of you, the teachers, like me, my colleagues, so you freely interact with me, whatever, wherever you are getting the doubts, or if I know, I will tell, otherwise I will learn from you. There is no mechanical losses. Mechanical loss, always it will be there. Okay, mechanical loss is there less than fuel cost. Very good, fuel cost. So nowadays you can see that 1 liter of petrol, 1 liter of diesel, how much it will be. Then mileage. Okay, mileage, you want to bring it with respect to the electric vehicle is more. Very nice. Nowadays, many they are working with respect to the rare earth materials. Do you know what it is, the rare earth materials? So, such materials are famous for permanent magnets and battery materials also. That's why nowadays battery size is less, but the power capacity of the battery is more. Earlier, you can compare your mobile phones. Earlier, during 2000 to 2005, you just compare the size of the mobile phone and nowadays. You just see that the power handling capacity, how much we are using. See, everything is based on the material. Very good. Then any other information? Then sound and vibration. Very good. Controlling may be easier. Okay. Monitoring. Very good. User friendly. Very nice. Then I brought in the title as AI. How the AI is supporting. Whatever the advantages which you are trying. Automatic control. Okay, fine. Automatic control. Okay. Then
autonomous vehicles.
okay. Okay. So how the role? I mean, what is the role of AI? Main role.
State of charge, state of
Okay.
performance of the vehicle and battery performance.
Okay. You want to predict the battery performance. Further, you want to use the AI. Okay, fine. Then safety. Okay. So you want to predict the safety. Nowadays, very good sensors are available with the vehicle. Even the driver is sleeping, you will get an alarm. So that AI-based sensors are available. MEMS-based sensors are available. Okay, then anything else? Yes. For basically we without AI also we can able to operate. When you want to have the sophistication or accurately if you want to operate, definitely you require the. If you want to operate accurately without AI also it will work. Definitely it will work. See, most of the vehicle like 3-wheelers, 2-wheelers and all, we cannot see the AI. Maybe some newly developed cars like a Nissan. Those industries only, they want to incorporate, they want to bring it with the AI. They want to have accurately trained data to have the real-time performance. I just want to bring in one more technology, digital twin. What is digital twin? I thought of telling, someone will open the term digital twin.
Sensors and monitoring which will be connected.
Okay, so sensors are integrated.
Sensor.
Okay, then do you have any idea about the digital twin? Nowadays, people are integrating digital twin also with the AI models like machine learning models, a DNN model, RNN model. Many models are there. So with that model, they want to integrate. So what is the difference between the simulation and digital twin?
Simulation is software part. The digital twins will control the hardware.
Hardware, real-time part, very good. So that means their physical system will be controlled, modeled and controlled through real-time process. So that means you are creating the model, but that model it will be based on the model you are controlling the real-time system. Based on the model you are controlling the real-time system. So that only we are calling as a digital twin. In fact, a digital twin also people are started to use in the electric vehicle applications. Okay, fine. So whatever the answer which you said, everything is fine. Okay. So the first one is started like no pollution. No pollution. This is the stand for our government. That's why they are promoting the electric vehicle. The other things and all, everything is based on the research. Based on the research. So when you want to complete, you can adopt any one of these technologies, whatever you discussed. Definitely you will get a PhD, definitely you will get the publications. And the patenting also. Just now I had a discussion with your HOD of this department. I said that the commercialization. Commercialization only the very big task. So when if the industry is attached, the industry also he must come forward to implement the technologies whatever you disclosed, like a digital twin, AI. Not in all the cases, very few, because they want to promote like this is a AI based. That's why they want to discuss. And so again it is a fundamental whatever we discussed. When you are referring the electric vehicle, the main part is the electric. Correct? The electric motor. So that electric motor which converts electrical energy to mechanical energy. For electrical excitation, we require the source. That's so for that source we are using with the battery. Okay? Or otherwise, we are depending with some other source like the renewable energy sources. Maybe the solar. Solar is a feasible energy source which we are recommending for the electric vehicle applications. So the advantages, whatever you listed in addition, like inspired by road going automobile and powered by electricity. Propelled by one electric motor or more using batteries. Electric motors give instant torque and smooth acceleration, one of you pointed out. So that's why nowadays people are promoted EV motors to the washing machine. You see that here, you just compare the application. Like earlier washing machine and the present day washing machine. Like a Bosch and all, you cannot find the vibration. You cannot, like how the vehicle is started, EV vehicle, similar to that, here also the washing machine will be started. So the motor is the main part. So everyone is depending on the energy efficiency. For energy efficiency, again we are referring the materials like a rare earth materials, particularly the permanent. That's why the permanent magnet motors are famous as compared to the conventionally existing machines like a DC machine, induction machine, synchronous machine. That's why everywhere we are talking about the brushless DC, permanent magnet DC, switched reluctance DC. So everywhere we are depending on the energy efficiency. I just want to quote this information here. And the plug-in electric vehicles are fast, fun, and efficient. Maintenance is simpler and cheaper. One of you pointed out the efficiency of the electric vehicle is low as compared to the conventional automobiles operated by a diesel or petrol. Okay, can you tell me? We the teachers, most of us, we studied the thermal. With that, we come to know the efficiency of IC engines. Can you remember? 35 or 40%. You are in the high end. So not more than 30%. So 30%, less than 30%, but we are spending more amount of fuel. So that's why sometimes we can refer the electric vehicles with the rare earth material of machines and batteries. So coming to the timeline, many speakers already they discussed. This is available in one of the textbooks. Most of the information I have taken from the textbooks. If you want, I will send you that same textbook, Electric Vehicle by Philip, and Battery Management System by Philip. So that textbook is a very nice textbook for understanding the mathematics. In fact, for teaching the UG and the PG course, we are referring to this textbook. And here you can see that the timeline. When you are referring, the electric vehicles are started with 1801. It is not new. It is not new. So it is started with 1801. But our people, we are talking with the 2020 only how the electric vehicle got promoted. What could be the reason? Why so many years? It was not developed that much. Yes, the technology. The technology like electric machine technology, battery technology, power electronics technology, communication technology, control technology, like a very recent AI technology. So all those things are famous. After 50 only many institutions we could see that many of them they started with artificial intelligence. Since the implementation is very simple, since the the technology development came with the technology originated with respect to the digital aspects. So the digital hardware came for implementation of AI. The real-time implementation. That's why it was not famous before the 2015 or 2010. After that, the technology started. So, very recently, I am a power engineer, basically. I know the development of power only with respect to the power, like the electrical machines, power electronics, control technology, the digital implementation. These things only we are working with our students. But many others, they are working with respect to the vibrations. I mean, the other aspects like reducing the volume, those things also they are working with respect to the mechanical aspects. I will discuss only the electrical point of view, how we are applying. Very recently they developed devices like wide band gap devices, WBG devices. So WBG devices also plays an important role in electric vehicle applications. So already in the power electronics, conventional silicon devices are available, but one can use the WBG devices. Definitely the size of the power electronic controller, it is going to be reduced, size and volume. So I just want to share my experience. Very recently I have developed one 500 amperes welding power source employing WBG devices, particularly silicon carbide devices, both for TIG welding and big welding, tungsten inert gas welding and magnesium inert gas welding, and multi-purpose welding, manual metal arc welding also it is possible. So I have developed, but the observation is the conventional 500 amperes welding machine has 200 kg, but I have developed with 100 kg with the laboratory level itself. If we are further commercializing, definitely the size it is going to be reduced with many times. So that's why with respect to the EV applications, one who brings the devices like this WBG devices, definitely the volume and the size of the power electronic controller it is going to reduce, particularly the size of the lead seats, size of the inductor, size of the capacitor. So those things it will be reduces. Earlier we used to have a very big strip for handling the higher rated current. Nowadays we are handling with the bigger width of the PCB itself with the higher rating current. Nowadays it is possible. So that's why when the technology develops, the other things also there. It started with the 1801, but it came in the market, or people are observing. This is also one of the research area and one of the commercializing area to reduce the CO2 emission. So based on the technology. Coming to this one, this we have taken from Hindu paper. Just to see that why we are again electric vehicle. So the air quality in Indian cities, the air quality and estimated depth also you can see that the air quality is very, very poor in Delhi. So followed by Mumbai, Bengaluru, Hyderabad, Chennai, Lucknow, like that. So everything is based on the emissions. That's why we are moving towards a green technology. Green emission. So we want to protect. So in this regard, we are moving towards the electrical vehicle. Coming to the concept. So whenever you are referring at the electric vehicle, I said that the electric motor converts electrical energy to mechanical energy. That mechanical energy we are transferring to the wheels. Okay. So that only we are calling as a load. This one. So sometimes this load it may be operated with respect to the two energy converter operated by individual source also, or common source also. So maybe the energy source 1 and the energy source 2. So I said that sometimes hybrid electric vehicle also it is available. When you are referring to the hybrid electric vehicle, it will be operated with multiple energy sources. So like solar and battery, then gas. That also possible. So under that case, if if you are having the energy sources, we require the energy converter. This energy converter sometimes it may be operated with a bidirectional mode also. Why you require the bidirectional?
Forward and reverse.
Not that one.
Battery regenerative.
Regenerative.
Very good. So, when you want to apply the electrical braking, we require the regenerative braking. There are braking many methods available like a plugging, a dynamic braking and a regenerative braking. So most of the places we are preferring the regenerative braking, but a very few places the energy is not a criteria. That place only we are preferring the dynamic. Other places we are using the regenerative braking only. For that reason only we require the bidirectional operation. And the types of electric vehicles may be the battery power, series hybrid electric vehicle, parallel hybrid electric vehicle, and series parallel hybrid electric vehicle, plug-in hybrid electric vehicle. So everywhere you can see that the motor is the main. So the motor is excited by the battery. So the important component is these two only. Important part of the electric vehicle is these two. Based on this only, you are going to play the advantages whatever you are doing. So like a zero emission, simple section, and a control of the traction system. So this is the generalized information. I hope the same thing discussed by the earlier speaker also. Like here you can see that the mechanical transmission is there. The mechanical power is received from the electric motor and it is excited by the source. So we are talking about the source always. The source is the battery, mainly the battery. In addition, we are operating with the solar. That's fine. So we have to use effectively the battery. We have to use effectively the battery for other auxiliary applications like auxiliary operations like power steering, vehicle controller, energy management, and these are the various possible combinations of electric vehicle. Here you could see that one main motor is there. Through gearbox and the differential we can transfer the mechanical power. Or we can use the two motors through the gearbox, we can transfer the mechanical power. The second unit. The third one is we can have the instead of the gearbox and the clutch, we can have it with one fixed gear. Sometimes we can have it the individual motor also. This and all you can see that in the two wheels. And this is the individual motor. Like this also it is possible. Like this also it is possible. These are various types. And the frameworks with respect to the electric vehicle is like vehicle to grid, grid to vehicle, then vehicle to home. Any kind of framework we can bring it V to X. Vehicle to anywhere we can power the. Very recently under CMRG scheme, I have evaluated one proposal submitted by one of the self-financing college in the Tamil Nadu. But they are written very nicely how they are using power from vehicle to X. So when the vehicle is in parking condition, whatever the energy acquired in the vehicle through the battery, so that they are transferring and they are using effectively for certain applications, powering some building. So since that particular institute is having 70 buses. So transportation. So they projected like this is just for the information. So the required features for electric drives is high efficiency, good performance, high power density, low cost, reliability, overload current capability, maintenance free, temperature resistance, and quality tolerance. So this is just an information. Now from the vehicle, how we are transferring power to other loads during the regenerative braking mode or during parking condition also it is possible. From the battery it is transferred. It is possible. So from the vehicle battery it is possible. Or otherwise we can feed the energy. When the vehicle is under running condition, that time we can excite the electric motor and feed the power to the electric motor. That also. So that's why I brought it like something like V2 load, V2H, V2G, or V2X. Anything is possible. This is another advantage with respect to the electric vehicle, and government is working towards this policy, battery swapping policy. Have you heard about this? So, battery replacement, but many difficulties are there. We do not know whether the battery is in good condition or bad condition. The year, many things we needed to be analyzed. Then only this kind of technologies to bring this kind of technology, it will be. So that means we need to be identified whether the batteries are standard batteries are. And coming to slowly I am entering with the topic. So here, this is just an information with respect to the bibliometric network visualization of research hotspots for the battery estimations. Here you can see that many areas it covers with respect to the battery. Just to see that many research areas, if you are catching one particular area, then your PhD will be completed. So the charge estimation, health estimation, useful life prediction, or the temperature prediction, degradation, runaway, modeling, transfer, and the state estimation. So CO2 estimation, the battery health state, all these things, see each and everything is the into your research problem. Coming to the battery management system, I am coming to the topic. With respect to the battery management system, what you are thinking about the battery? This diagram is self-explanatory. It looks to be, you can see that it is represented with the power management. It represents with the thermal management. It represents with the isolation fault detection. The right hand side you can see that cell balancing, voltage control, current control, thermal control, all those things it is involved with the battery management system. So when we are carrying out the research, we can have any one of the blocks and we can have we will be expertise in a particular domain. So for example, cell balancing or voltage control or current control or thermal control. Our students are, most of them, they worked with machine design. That is one thing. Second part is they want to bring it with the rare earth material and they want to test it with the machine and efficiency and all. The second thing is the power electronic controller with respect to the battery management systems. I think yesterday a speaker from Amanta Madam spoke about the power electronic controller. And one of my students presently pursuing with respect to the self balance. He is using 1 ampere hour lithium ion battery. He experienced a lot with respect to the 1 ampere hour battery itself. He blasted only one battery. The size of the battery is this much. Our laboratory size is this much. But smoke is key. Then he realized he had to operate very cautiously. I told him, he called me during night at 12 o'clock, sir. One battery got blasted, but heavy smoke came in the laboratory. What I have to do like that? I said that immediately you open all the windows, you come out. So you have to be very cautious while operating with the batteries. It is not so easy. It looks to be easy, but it is not so easy. So very recently we came with news from Karnool, one bus accident. You see that very number of cell phones with the battery only that accident happened. So we need to take care while operating with the battery. That's why we need the accurate control. For getting the accurate control only, we are moving towards the AI. Without AI also it will work. But AI, when you are moving with the AI, again you have to spend a little more. That's all. If you are observing with a few indications, then you will be alert, then you will remove. If you are not alert, you require definitely the sophisticated, like a fully automatic system, fully automatic vehicle. So this is an overview of the battery management system. So coming to the BMS for EV applications, here you can see that how it will be the BMS. So it is depends upon what are the parameters. Each one is again I am telling you the separate research area. So here you can see that the power is feeding to the EV. We are having the cell battery pack. Through the battery pack only we are having the charging and charging and discharging. When you want to have the battery management system, you require to have the capacity estimation, SOC, SOH, thermal management, so measuring unit. Then sometimes it is required the cell balancing also. And sometimes if you want to have the control with the cloud, CAN bus control, Modbus control, those things will be. So this is the framework for developing digital twins. I got it that just information. This slide I have taken from very recently published AICTE article. Yesterday my student has discussed. I said that this is also how they are applying the digital twin with respect to the battery management system. Here you can see that it is block diagram and what are the inputs is there. Here the battery pack is there. So we need to have the state of the sensor, then only we can feed it to the control signal for operating the vehicle, correct? For operating the battery. So that information you can observe here. This is the vehicle. From the vehicle, from the vehicle, you are interfacing with the battery, and the battery is the main part to excite the motor. And the BMS, whatever I showed. And we are sensing the real-time data. Madam pointed out very nicely about the difference between the simulations and digital. So how we are having the process control with respect to the real-time operation? We are going to mimic the model of the real-time system Based on that only we are controlling the real time. So this is the input data, our objective, that model is here. So the data driven, the output it may be the voltage or current or temperature or anything it may be. So in this regard, people are using with many AI technologies, many AI models like a DNN, RNN. So like that they are using, in fact SVM, Kalman filter, they are using nowadays. Those things are, implementation of those things are, I can say that easy, but the only thing is you are to learn. Many open source materials are available. You need to be materialize that one and how you can use on your application. So what are the data are required? What are the information? It is available with respect to the digital twin technology. So those things it is represented. In fact, this is a very good review article. If required, I will share. And here you can see that the framework. Compared to the earlier slide, you can understand clearly. Like real world data, digital twin, then digital state of the system, then again we are using the ML for prediction. And based on that we are observing the energy prediction level and power consumption to the load also we are predicting. Then the RL algorithm. So decisions and actions like charge of the battery, discharge of the battery, then maintenance of the battery, apply action to the real states. This is only happened. I started to tell, even nowadays, all the vehicles are fully automatic. Everything is sensor based. Very recently, one of my friend, he purchased a Creta vehicle, the full, top model. In that, the driver is about to sleep, immediately he is getting an alarm. So at reverse also, while he is driving with reverse direction, it is observing very clearly all the objects and giving alarm to the driver. And coming to, slowly I am entering with the topic technically. So far I am discussing the flow and what are the information which is available in the electric vehicle. So coming to the state of charge. State of charge. So state of charge indicates what? I have given all the information from the slide itself. What you are understanding from the state of charge? So how much charge which is available in the battery? How much charge is available in the battery? So that only indicates the state of charge. It is equivalent to the fuel gauge in the vehicles. Correct. So it is expressed as a percentage. SOC represents the remaining capacity by rated capacity. See, for example, 40 ampere hour remaining in the 100 ampere hour means the SOC is a 40%. So that means the 40% only the available fuel. Available? Madam, I will share the slide, madam. Don't worry, madam. All these things are fundamentals only. Whatever the slides which I have prepared, except few things unpublished work alone, I cannot give because presently the students are pursuing the PhD. So for that reason, I cannot give. The other things I will. So here, you can observe the characteristics. This is the voltage with respect to the voltage and SOC characteristics during charging and discharging mode. This we are observed with respect to the 1 ampere hour lithium ion battery display. I told you that battery only got last time. So the fumes entire room, we observed the fuse. Then immediately I told him to open the doors, all the doors, windows, everything. He came out for the 3 hours. Then he locked the room. Next day he reported. So I told that the significance and the importance of the battery management system. So while operating, we must take care. And here we can observe that while charging and discharging, how it will be with respect to the SOC. When 100% of the SOC means the battery is getting fully charged, the voltage is getting increases. When the voltage is reduces means that significance we observe, it is getting discharged. And coming to the another important parameter with respect to the battery management system is the state of. So state of health means it is a battery aging and degradation. Battery aging and degradation. This we need to understand, then only we can go for other. And it shows how health battery is compared to a new one. So it is defined like current maximum capacity by initial capacity. So for example, the new capacity is 100 ampere hour. After capacity means 80 ampere hour. So that will be needed to be estimated. So for that reason only we are preferring the AI models, machine learning models. So DNN model, SPM model, Kelvin filtering model. And coming to, this is the fundamental difference between the SOC and the SOH. And affected by load and temperature, that means that represents the SOC, whereas SOH is aging and cycle. So basically it is a range estimation, it is a life estimation. And coming to this flow, this is also the same article which I have taken this diagram, published article. Here you can see that we are moving towards the advanced DMS. DMS we can achieve while having with the SOC estimation above. BMS we can achieve with only SOH estimation above, or cell balancing estimation above, or one is integrating all three together. All are possible. So here you can see that the data source, it may be the lab based or field based. The data process is harvest, sometimes it is moving or reconstruction. The feature representation is the charges, constant voltage charge, constant current charge, ICE or anything. The applications it may be like cloud computing, digital twins. So like this is the flow. So the data estimation approach is an experimental based. It is an experimental based. It may be the direct or physical model based or digital twin based. So when you want to bring it with the digital twin, definitely the model is required. And the feature analysis based on. So everything is based on the data driven. So it may be the neural network or data enhancement. So neural network any one type or transformer based, data transfer, reinforcement, all these things. When you are referring each one block or information represents with one result. One of my students is working with a guy. He basically is from a computer science is UGD. But the PG, because of the university, they opened power electronics also for computer science engineering few years back. Then he studied, but he is very much interested again with the electric vehicle. I said that I told him to work with the cyber security of the electric vehicle. This is the the estimation of SOC and SOH. So with respect to the BMS operation, so when you are having the new energy vehicles, the new energy vehicle means it represents with the component, battery type, benefit, all information that will be available. The BMS represents with the state of health, state of power, state of charge. So that we are arriving from the temperature, internal resistance, charging and discharging. Then the estimated techniques, any number of estimation techniques is n number of estimation. One is with working estimated techniques alone, you are able to do. So the research for each one is a separate research. But I am using very one student he has used with the estimated techniques like based on the open circuit voltage or model based or electrochemical model or equal circuit model. So we need to use when you are commercializing the BMS, you need to see that which one is the feasible, which one is the cost effective. So again, when you want to commercialize, the people will ask how much is cost. That is very important. So then the purpose, safety, accuracy, real time, simple. So again, AI means if you are bringing, you will get accurate. But ultimately, when you are commercializing, how the cost. So the estimation methods. Mainly for BMS, battery management system, we are going to predict or estimate. That estimation, it may be the online estimation or offline computation. So mostly we are preferring the online estimation. It may be the model based, it may be the bookkeeping, or it may be the direct, or it may be the adaptive filter. By employing any one of the methods like the equal circuit model, electrochemical model, or pole counting model, or modified pooling model, or open circuit voltage, internal resistance, output voltage, or partial filter, the other technique like fuzzy neural network, Kalman filtering method, anything is possible. But each one is a individual research. This is one of the models, the cooling counting model. With respect to that, how we are estimating the SOC, with respect to the battery current and with respect to the cell current, with respect to the cooling counting. And this is the open circuit voltage method. We are measuring the voltage and the current of the battery based on the model. We are going to find it out the open circuit voltage based on the mathematical equation. Nothing else. So here, this is a simple method. But the thing is, again, we want to implement this, we require one digital partner. So sometimes we are preferring with a model based. So for example, the Kalman filter model. Many models it is available, grid model, Thevenin model, like that. So based on that also it is possible to estimate the required parameters. And this is also one of the model based, it is called as a Kalman filter model. And when you are referring the comparison, then you are like what are the things it is existent with respect to the existing models like a ML model, GNN model, DNN model. So what are the advantages and disadvantages it is indicated in that review article. Finally, they want to conclude that when you want to go with the accuracy, when you want to have the operating simpler, in that case you require AI based model. This is only the conclusion. But here the AI model estimations, it may be the it is depends upon like a time of series data, captures at temporal dependencies, so and stereosis. So it may be the RMN model or LSTM model. Sometimes it may be required with the artificial neural network. Sometimes we can have the life estimation also with the support vector machines. This is the one of the case study I just want to discuss with respect to the battery balancing. Whatever the research work carried out by our. So I said that the PMS is the integration of SOC estimation based on the SOC, based on the SOH, or based on the RUL, or based on the cell balancing. So we are operating the battery effectively, accurately. So for that we require one component is the cell balance. So what is cell balancing? You just see that. From the diagram, the first diagram represents, you can see that in your battery bank, So one battery looks to be the higher charge. So here these are other three are equal charge. That means what? The mismatching. Mismatching of the SOC in between the battery cells in the pack, it leads to huge amount of charging energy. Similar to the solar array. In the solar array also many panels we used to have the series and the parallel connection. According to the current rating, we used to connect with the parallel connection. And according to the voltage rating, we used to have the series connection. Correct? Similar to that here also. So our observation is a mismatch. When mismatch occurs, what is your observation? What is your observation? So, yes, what is your observation? There will be a loss. See, originally the capacity of the battery, let us consider 100 ampere hour. But because of this unbalancing, because of this mismatch, you are not able to use the capacity of the battery. So that only the mismatching restricts the capacity utilization of the battery. And driving range could be minimized. Correct? Ultimately, that one is reduced. Then leads to electrical accidents. So require more time for charging. Lifetime of the battery pack is also reduced. This is only the observation. So in this regard, a simple technique he has applied for balancing. Before that, there are two types of balancing is there. So that is called as active balancing, another one is a passive balancing. So passive balancing means waste the excess energy with the passive elements. And active balancing means mutually share the energy between the cells. So before balancing, for example, cell 1, cell 2, cell 3. This here it is indicated with the percentage of the SOC. And after passive balancing is this much. The active balancing is this much. What you are understanding by looking the diagram itself? So the active balancing, when you are applying the active balancing, the SOC level it will be increased just by looking the diagram. How it is increased? That I know. So how it will be? Because mutually shares the energy between the cells, whereas passive balancing is waste the excess energy with the passive elements. That's why the SOC level is little higher, but it is getting reduces. That's why most of the places we are moving with the active balancing techniques. So coming to the active balancing technique, how we are implementing. So we are having with the constant voltage or constant current charger, battery pack, the switching circuit, and and inspect the SOC of each cell. How we can measure? Based on the sensing, the voltage and the current, or based on the estimation, it is possible to sense the voltage and the current of the each cell. So then we can understand where we are getting the unbalance. How we can balance. So in this regard, one of the case studies are employed in our student. So here you can see that the general block diagram for active balancing, how it will be. So this is what the higher SOC part, and this is the lower SOC part. In between, he brought it with the switching matrix circuit. Switching matrix circuit. The way in which he is reconfiguring the battery, he is going to have SOC level is more. So how he is going to achieve this one? This is the fundamental principle of active balancing. So a simple flow chart for active balancing technique is, so we have to inspect each battery in the battery bank and measure the SOC of each battery, find the maximum SOC and the minimum SOC level, parallel the maximum and the minimum SOC level of the batteries, connect the parallel configured batteries with the remaining batteries of series configuration, and connect the battery charger, then charge the battery bank. This is only the flow chart with respect to the active balancing, and this is he tested with simulations, and when he is testing how it will be the average SOC battery bank, it is getting improved with the different cases which he considered. How the average value of the SOC it is getting increases, that he has observed with respect to the active balance. Now coming to the topic. Simple technique, that is the principle. By principle. By principle he has observed. When you are applying the AO SOC, I mean the AA model. AA model, so from the beginning onwards, we started to tell the AA will provide the accurate result. For getting the accurate result, we require the large number of data. That data, it may be the real-time data or offline data, whatever it is. So this indicates with the BMS. The BMS requires the voltage, current, temperature. The output application is the SOC, SOH, and the status of the part. So this is the example with respect to the fundamental construction of the ANN. So we are having the input and output, and we are having the hidden layer and output layer. How it will be 1, 10, 1, 1, which we are getting. So nowadays we are having the tools directly, like a MATLAB tools. So directly one is using the MATLAB tools, you can implement the NN, ANN, DNN, all applications. So those tools are directly you can integrate with the real-time processors, like the FPGA processor or embedded controllers. Then the implementation of the controller is also simple. And the AI-based modeling, battery balancing, how it will be. Here you can see that a single tri capacitor based balancing, AI-based model topology. Here you can see that the 3 batteries are there, B1, B2 and B3. And through the capacitor they are balanced. Basically it is a voltage balance. And the second thing, double-tried switched capacitor based AI-based balancing. Here you can see that the same thing. With respect to the switched capacitors, whether you want want to connect it here or here, that decides by the control switch. That decides by the control switch. And here this is another methodology or topology, that is modularized capacitor based topology. So here you can see that the same thing, the capacitor we brought it, the battery we brought it, depends upon the SOC level, we need to connect a particular capacitor. And this one is represents with the switch to transformer based. That is some energy we are transferring. Energy in the sense we want to balance the voltage level. So for that reason we can go for this also. These are the commercially available technologies. And when you are referring the flow, how it will be. So when you are having a voltage, current and a temperature, you need to add the weights. After weights and having the activation function, you will get the switch control. So this is the represents with the BPN, and that represents with the BMS data association, data processing, training the data, testing the data, validating the data, then we can have the model. So if the best performance is achieved, so with this little modifications people are doing and they are getting to the problem. And this is the represents the training results. So okay, I just want to stop. After that, one more case study is there. So here you can see that the comparison and training the data with respect to the states of the plot and performance plot, the states of the plot, then fit function, then error. So when you are applying the comparison is I want to bring it at this parameter. So you want to commercialize cost. I will ask how much this cost. You are showing something, how much this will cost. The cost of the. So here the cost is, this is cheap, but a higher cost, but accuracy is good, efficiency is good. So I mean here the average higher cost. The other things, most of the things we can achieve here also. Then we will discuss the case study. Very recently we got IEEE transactions on industrial electronics. So with that I just want to discuss one case study with respect to the battery balancing. After having the break, we will discuss that case study. Very simple only. Yes.
You are requested to reassemble at 11:10 a.m. Thank you.
This work has been published in IEEE transactions on power electronics, not power products, industrial electronics. So here we used the very simple technique. It is not AI or something else. Very simple technique. That's all. This is we can find with respect to the research point of view. So adaptive reconfigurable battery pack employing switching matrix circuit to maximize the capacity of the battery. So earlier I said that the active balancing versus the passive balancing, you can see that how it will be. So and where we are getting the capacity is more with respect to the balancing, that also we had a discussion. So we projected the active balancing only good as compared to the passive balance. So here, actually my student has prepared, he has to give one, for his PhD requirement, he has to give one seminar, for that only he has prepared this. In this, reconfigurable battery pack is proposed to enhance the performance of the battery pack for electric vehicle. The SOC mismatches between the battery cells in the battery pack will limit the capacity utilization. This is only our observation. The proposed system employs the MOSFET-based switching matrix circuit to reconfigure the battery pack based on its present state of charge to mitigate the SOC mismatches between the battery cells in the battery pack. In this regard, we are used with the adaptive part of the battery cells, which enhance the fixed part of the pack with the proposed switching matrix system, converter system. And the technique will maximize the capacity utilization of the battery pack under the mismatching level while charging. So this we tested with respect to the charging addition. The proposed technique achieves the maximum capacity of 97.7. So this is only our target. Coming to the block diagram. This block diagram explains very clearly. Like one battery charger is there, that battery charger, it may be the constant voltage or constant current charger. We are provided with the 4 batteries. The 4 batteries like a B1, B2, B3, B4, in between be connected with the switching matrix. So this is only the relay on during the charging period, the relay off during the self-balancing period. And switching matrix circuit is operated during the dynamic reconfiguration. Dynamic reconfiguration. So coming to this one, now you see that the conventional methods of battery arrangements. Conventional methods of battery arrangement. That is interconnection configuration of the battery pack in the electric vehicle applications. The first one represents the series configuration. The second one represents the series parallel configuration. And the third one is represents the parallel series configuration. Sometimes it is called as the totally cross-tied. Cross-tied. So these are the configurations we are using in the EV applications, battery connections. Cross-tied here. Yes, these 4 are in parallel. We are having the tie here. So this is the connection. This is a type of connection. With respect to this connection, we need to be observed. This is the existing connection. Parallel also you could see that this is also possible. This is also possible. So here, now, the proposed configuration is, you can see that the before configuration and after configuration, how it will be by employing the switching matrix. Before configuration, first you can see that this is 70, this is 70, this is 70. This is 50, 50, 50, 50. So this is what this represents with the first column, second column, third column, fourth column. And the adaptive part, how we are bringing before configuration, how it will be, the after configuration, how it will be. So here we are bringing first the fixed part. Fixed part is this side. The adaptive part is this side. So that when you are referring with the adaptive part, here it looks to be 60%. This 60% we brought it here, and 80% we brought it here, and another 50% we brought it here, and we considered with the switching matrix circuit is here. So how the way in which we are considering, you can see that the fixed part represents here, and adaptive part is represents here. So in this system, the battery is categorized into 2 components. I mean the 2 parts, it is very clear. The first column of the battery cells was considered as the adaptive part. The adaptive part will balance the fixed part of the fixed part of the battery. Adaptive cells or adaptive part will balance the fixed part of the battery pack. So the switching matrix circuit will reconfigure enter the adaptive part to balance the mismatch between the fixed part. So how the SMC, the switching matrix circuit, it will work. How the switching matrix circuit it will work. For that we have applied one a simple logical circuit. That logical circuit explains like this. So this is that flow. Here you can see that the flow chart represents, initially get the values for the battery bank. The battery bank, it may be the M cross N or M cross N. It may be. Read the SOC of the each cell of the battery. How we can read? Instantly, how we can read? Based on the current, or based on the voltage and current, based on the model, or we can go with accurate estimation, ML based or DNL based, anything. But instantaneously we need to be observed. That is a separate example. We have a sensor, current sensor. Based on the current sensor, we have estimated the SOC. And whether the SOC level is less than that DOD level, then we need to be stopped. So if it is not no, we have to apply the ranking mechanism, rank the battery on the adaptive side based on its SOC. If it may be the ascending. So rank the battery on the fixed side of the battery, their average value of the SOC with respect to the descending. Then operate the switching matrix converter circuit and connect the battery cells based on the rank. So we are following the ranking. Based on the ranking only, so then change the battery bank. That means interlinking connection, it has to be changed. That interlinking connection, it is depends upon the SOC level. So for that, our technique starts from here to here only, these three blocks only. So rank the battery on the adaptive side based on its SOC by ascending, and rank the battery on the fixed side of the battery, their average SOC descending. This is our novelty. Very simple novelty, nothing. Yes. Yes, correct. Then I will explain about the initial condition, how it will be, the final condition, how it will be. With respect to this configuration, then we need to have the change the battery bank. I mean the charge the battery bank. Maximum capacity is attained or not. There also we need to have one decision. If it is not, we need to again reconfigure. So then if it is yes, we need to stop. The illustration represents the process of configuration for the test case. The first case you can see that before configuration. Before configuration, the B11 first row. The first row is 28%, 25%, 27%, 26%. B21 47, 37, 35, 39. Similarly, you can observe B31 63, 53, 50 and 56. So this is similarly 74, 80, 70 and 60. By applying this row chart, you can see that we are bringing the two parts, like adaptive part and fixed part. So in the fixed part is we are bringing 25, 27 and 26. This we are considering as the adaptive part. And similarly for other row also we identify. But based on the ranking, you need to have the interlinking connection. You need to have the interlinking connection. After that, one can observe the average SOC is how much it will be. So this is after reconfiguration. This is the finding average value of the SOC is represents with 2.6%, 3.7%, 5.3%, 7%. Then after reconfiguration, so we are bringing here the highest value we brought it here. 74 percentage, this is 63 percentage, 47 percentage, and 28 percentage. This we kept it as it is, you can see that. And by applying the ranking process that represents, this is the rank 1, the rank 2, rank 3, and the rank 4. This is a 4, 3, 2, 1. By applying the flowchart. So with respect to this condition, the initial SOC is how much with respect to the various configurations which we proposed. The first one represents with respect to the battery B11, B21, B31, like that, B41. So here the initial SOC it is indicates, for series combination it is indicates the capacity, I mean the watt-hour capacity. The watt-hour capacity, how much it will be for each one we observe. This is with respect to the series parallel. This is what represents with the parallel series. This is only with respect to our switching matrix circuit by adaptively reconfiguring. So under each case, you can see that the capacity utilization it will be increases. This is only the objective. The same thing we experimented and submitted to the identity transactors and industrial electronics. Very recently we got access. So the simple idea only, but the remaining information and all it is existing. But different mathematical analysis with along with the case studies we projected in this one. This is what the four case studies with respect to the four performance comparison like it's a mini series configuration, parallel series, parallel series are proposed. So how it will be the cells in the battery pack and the corresponding SOC, those things we observe, and the capacity comparisons also we observe. So definitely the capacity comparison it will be very simple work only, and the various configuration how the capacity is increases with respect to our proposed configuration for each battery. That all. So the concept is one place we are arranging the battery in ascending, another place we are arranging in the descending, and we are applying the ranking process. And the outcome of this one is the maximum of 97.7% of the capacity from the rated units. But while testing this one only, he blasted that 1 ampere hour battery. But the fumes in the entire room, he got it. And because that fumes are not good for the health, so I told that immediately you can come out from the lab. Okay, this is the one of the case studies. Actually, my students, many they are working with respect to the power electronics. One of the students he tested how it will be the vehicle battery to X, vehicle battery to grid or grid to vehicle. So one side he has connected with the vehicle, the another side he has connected with the battery. So he has used with one H bridge. So this H bridge it will be acting as a AC-DC converter or DC-AC converter bidirectional. The another side is this one is the conventional buck boost power converter. Conventional buck boost power converter. We want to test it the power in both the directions, bidirectional operations. So the buck boost power converter, when you want to operate with boost, what I mean buck operation, the power it will go from this side to this side. When you are operating with the boost operation, the power it will go from this side to this side. So the objective of this work is he wants to maintain unity power factor at the supply terminal. So for that the unity power factor rectifier he has used. That's all. He has tested both the simulations and experimentation and he applied the synchronous machine concepts. How he is controlling the grid real power, reactive power, those things also. So he is calling as a STATCOM based, vehicle based STATCOM, EV based STATCOM. That also for microgrid applications and nanogrid applications. System is same only. The way in which he is projecting, that only it is different. So he has tested how the battery current is positive and the battery current is negative, but a VDC is always positive. How the power flow, it will be the one direction and the direction that can done. So the THV and he has verified. And one more student, he has developed the charger, onboard charger. So onboard charger for with the power electronic applications. So he has considered with the lossless direct path reinforced bidirectional DC-DC converter for onboard charger in electric vehicle. So he is telling that lossless. First you can observe. Everywhere we are depending on the efficiency. He is telling that it is a lossless. So that means when he is transferring power from one place to another place, he wants to achieve lossless. For that, what kind of configurations he is going to have. So this and all already we discussed. So actually the electric vehicle based on the charger unit location, it may be the off-board charger. Off-board charger means, so the entire thing it will be in the outside. Whereas on-board charger means the entire unit, the charging unit, it will be inside. So there the objective is we want to reduce the size and the volume. So the more charging flexibilities we'll have when you are having with the on-board. That's why many of them they want to have the on-board charging. Otherwise, you need to have the compatibility between your vehicle and the charging station. And require a high power density charger unit. This is not much expensive. So in this regard, normally, when you are using with the charger, the structure of the onboard charger, it looks to be the first stage is the AC-DC converter. The second stage is the DC-DC converter. We is going to have the charging. The essential needs for onboard EV charger is a less number of power conversion stages, high power density, high efficiency, bidirectional power flow, like that. So he has applied many literatures. The gap which he has identified is he wants to have efficient and compact DC-DC converter is needed to improve the onboard EV charger to get the overall performance of the system. Then the bidirectional power flow also he just want to bring it with the V2X. So then in this regard he has chosen the DAB based bidirectional DC-DC converter. DAB means dual active bridge. Now we are using the tri-active bridge, 4-active bridge, 6-active bridge with the same transformer. So 6-active bridge, like in the first slide I showed how it will be the structure of the EV, in that the major amount of the power from the battery which we are feeding for mechanical translation mode. So remaining power, a few amount of the power we are using for the vehicle control, like steering control, AC, those things we are using. So for that also we are taking the power from the battery only, but the vehicle is running. So in this regard, he has chosen his objective is a single, he wants to have the DAB based power converter and single phase shift controller he has applied. So he has verified both experimentation and simulations. So now this is for the structure of the system which he has chosen. Actually, he is a part-time candidate. He could not get a good publication, but he got with the Scopus journal. This is represents with the dual active grid isolated with the transformer, high frequency transformer. Here you can see that one configuration. What is the difference? The load is the battery. The load is the battery. One point of the power converter, it will be connected directly to the battery. The another point of the power converter, it will be connected to directly the supply. So from this, what advantage we can claim? The major amount of the power which we are transferring through the direct power. The major amount of the power we are going to transfer through direct power. And the variations in the power, that power alone we are transferring through the power converter. This is what he is saying. He is telling that always I just want to transfer 50% of the power to the main terminal. I will through direct. The another 50% only the variation. So he identified how it will be the driving cycle of the particular vehicle. So for that reason he has applied the control is like a single phase shift controller. So this is the controller, it may be the constant voltage charging or constant current charging. So for that he has sensing with the voltage sensing and the current sensing. In the experimentation we used to have a LEM-make voltage sensor and a LEM-make current sensor. And this is that circuit. High frequency transformer. And here one is spirit, here one is spirit. The converter looks to be the two port. One is the supply port, another one is the load port. So the major amount of the power which he is transferring through here, the minimal amount of the power only he is transferring. In this regard, he has applied the control technique is the phase shifting controller. So the phase shifting controller is the VDC. This is the VDC. This is the with respect to the number of terms, how it will be the VPP. So he is referring to both the voltages. Based on that, he is generating the pulses. How it will be. So this theory actually you would have studied in the synchronous machine. In the synchronous machine, both the places we are considering with the sinusoidal quantity. This is what E. This is what E. E into V divided by X into sin delta, that is the power transfer. The same concept only we are applying. When delta which is equal to 90 degree, you are getting with the maximum power transfer. Like that you are proved in the conventional theory process. But here the thing is, both the phases are square wave. Both the phases are square wave. PWM. You need to apply the fundamental. So by applying the Fourier series theory only, you need to have. Similarly, the discharging. The discharging, how it will be, that also he has verified. So the different operations he has applied, with respect to the power converter operations, how it will be the charging case with respect to the mode 1 and mode 2, how it will be transferring the power and the corresponding the typical waveforms. Similarly, mode 3, mode 4, how it will be for charging case, how it will be for the discharging case. Those things he has verified, but only thing is he has to maintain higher voltage one phase, lower voltage one phase. Then only in the DC system, the power it will be transferred. In the AC system, with respect to the delta, load angle, the appropriately if you are adjusting the phase shift, I mean the theta, then only the power transfer it will happen. So that principle only he has applied. He applied with he found with the two paths, this is the partial path, this is the direct path. Under that case, he has derived all the voltage equations, current equations, the power equations with respect to the battery, charging and the discharging conditions. And he has analyzed how it will be the power transfer along with the losses. So those things he has analyzed, how it will be the direct path, how it will be the discharge path. Where in the direct path there is no losses. In the discharge path only the losses. And he has analyzed everything. This is what the control. How it will be the constant voltage charging and the constant current charging. How he has generated the pulses. So those things it will be there. When constant current charging represents the 10% of the SOC and 90% of the SOC is this much he has considered. And he is using the single phase shift controller with the help of he has implemented with respect to the negative edge triggering JK flip-flop only he has. And these are the specifications. So I am showing within 15 minutes, but he took more than one year for implementations. And different parameters he has shown. And he has observed both the simulations and the experimentation. This is the for charging phase. He has considered the battery capacity is this much. I mean 80.5 amperes. Under that case, how it will be the direct path power, partial path power, how it will be the corresponding ratio, how it will be the efficiency. Those things he has analyzed. The corresponding efficiency is also he has analyzed. So the power sharing ratio with respect to the partial power and the direct power, how that ratio, how it will be, that also he has analyzed. He is claiming that the very good advantage he is getting with respect to the single stage power conversion. That too, major amount of power he is processing directly. Minimal amount of variation in the power only he is processing through the partial processing power converter. He is claiming this advantage. What you are thinking the disadvantage?
Direct path.
No, madam. Directly we are connected. The circuit looks to be directly connected, no? The circuit looks to be directly connected. Then where is the resistance? Here only the power converter comes into the picture. Definitely the partial path is having the losses. Direct path is not having the losses. Then what is the other disadvantage which you want to tell?
The input you are given was an AC source. Where you are getting, where the vehicle is traveling. How to get the AC source?
Where, madam?
First,
That is not the AC source, madam. This is the DC. This is the meter.
AC source onboard charging.
Yeah, onboard charging.
DC source.
So this one only the onboard charging is there, no? This AC-DC power converter is also embedded in the vehicle. Only 2 points it will be there. Directly you can insert in your home. Not vehicle itself, madam. This is only the vehicle. And the point metal. So that 2 points you need to insert in your plug. It is not. See, the grid will not be available in the moving condition. Yes, ma'am. So this is only the vehicle. This part only it is available in the vehicle. This is the onboard charger. Onboard charger means everything is embedded in the vehicle. So if you want to charge, I mean, உங்களுக்கு charge பண்ணனும்னா ரெண்டு வயர் மட்டும் கொடுப்பாங்க. அந்த ரெண்டு வயரை கொண்டு வந்து இங்க சார்ஜ் பண்ணுங்க. Correct. No. எப்படி மேடம் கிரிட் யூஸ் பண்ண முடியும்? But that it is possible. எப்படின்னா the wireless power transfer அதுலலாம் possible. So another student is working with respect. He has developed the two coils, transmitter coil and the receiver coil. Based on that, the distance. Correct. That also possible. Any other disadvantage which you are finding? I thought you will tell. There is no isolation between the source and the load. This is only for this reason only he opposed to publish in many journals. Then we found one standard. I'll show you that standard. With respect to that standard, in that particular article, he said that when on-board EV charger, the isolation is not required. So we claimed that advantage. So after that only you can able to publish. This is the results corresponding to the charging, discharging. This is the experimentation which he has done. Say from the switch onwards, like developing, soldering, PCB making, purchasing the component, everything we used to give the training. So in our institute, we used to provide the facilities. Student, they used to fabric. They never purchased anything or anywhere. All the programming, even FPGA programming also he made. This is the gate driver circuit. So high frequency transformer, you can see that how much size. So I can say that this IGBTs are carrying the current is up to 10 amperes. That much he understand. Many studies he made. You can. That's why showing within 15 minutes it is so easy, but it took a lot of time for that. So this is the experimentation results, and he tested the change in, the transient results also, how the power it is changing, direct path power, partial path power, under the charging case, under the discharging case, how it will be, those things he has tested. And the experimental validation also he has done, and the efficiency also he observed. And the comparison with the similar works also he proposed. So the important advantage he is claiming that bidirectional power transfer, direct power transfer, charging efficiency, discharging efficiency, those things he has considered. And this is what is achievement. So the same work he has extended with another aspects. Instead of feedback, he has considered the feed forward, the voltage. So earlier I showed the two sensors. He has used only one sensor. The feed forward voltage he has applied with respect to the DC link voltage. The same analysis he has executed, and he has derived, and he has tested everything. This work is published in one of the Elsevier journal. The first one published is that same experimental setup, and how the gate drivers and all he fabricated. This is the experimental data. And so yes, he has tested the efficiency also. Analysis also he made it. The comparison also he made it along with the efficiency. This is only the limitations I said. It does not provide any galvanic isolation at the DC-DC stage. It may be used this standard. It is applicable for this standard. So according to this standard, we made. So here this is what the plug here they used to give. Under that case, like the terminals it is indicated like neutral terminal, connection switch, protection here, the control pilot like that. So the PE terminal of the OBC, onboard charger, will take care of the protection from the electric shock. Yes, non-isolation of the DC-DC stage will not be a problematic. This is only our control. Actually, we rejected the particular work got rejected in IEEE. Then we submitted to the Elsevier. Elsevier got accepted only because of this. So this is only the convincing point. So strongly we written along with the entire reference material with respect to this standard. That's why this work got accepted. Otherwise, everybody will ask, where is isolation? So, this is another student carried out with respect to the answers. Basically, it is a design of machines. So now he is applying the AI also, machine learning algorithm also. So to predict the multi-objective option. So here I started to discuss with respect to the electric vehicle. The important part is electric motor. The electric motor means the design. So for design, people have started to use the rare earth materials, neodymium and other things. So the cost is very high. Those materials cost is very high. That's why many research is going on in the space. In the space, many materials are available. So those materials we need to bring it here and utilize. And this is the evaluation of reduced rare earth interior consequent core component magnets. So here our design we incorporated that the rotor design only. Rotor is a permanent magnet. This is the armature winding. The rotor magnet it is an interior permanent magnet. So instead of having the one layer, we made it with the two layer. And this machine we compared with respect to the conventional Nissan Leaf interior permanent magnet. We have taken that data and our design data where we are getting the torque ripples are less, current ripples are less, losses are less, efficiency how it is going to be. So those things we validated theoretically and simulations. This is the parameter, how many slots and other things, permanent grade. And important observation is we observe torque to current ratio and torque volume and weight. The weight and all it is going to be reduces. So how you are going to be optimize each parameters, for that we have created the multi-objective functions that also, and the flux distribution how it will be with respect to the loading conditions that we have verified through the answers, and how it will be the open circuit voltage, that is the air gap flux density with respect to the rotor position, and how it will be the harmonic spectra with respect to the conventional machine and Nissan. Then how it will be the torque, how it will be the torque ripple, those things and all we have evaluated. And so by employing this one, how it will be the iron loss. So those things, those analysis we made it. And this is another type of area which we can work with the electric vehicle. So Anna University College of Engineering Hindi, they are working towards design of electric machines. They are doing extensive research in that area. This is another student, he worked with brushless DC. He has developed for torque ripple minimization. For torque ripple minimization, he has applied a simple voltage modulator. So, in that voltage modulator scheme, he has applied this one. The remaining control schemes and all, everything is same. And he has applied the very less torque ripple, and he has compared the experimental setup in the institute. So, then, I just want to show you how it will be the Indian charger standards, like the AC charger, DC charger, and finally, I want to tell the government policies. Since we are attending many functions, many bodies, government bodies, we are also participating as a member. So, particularly like NITI Ayog. So, the NITI Ayog, the roadmap transformating mobility solution for R.
So 2021 PLI scheme, that is a production linked incentive scheme is also there. If you are referring this website, NITI, Niti Aayog, you will get lot of information about the electric vehicle purchase and the incentives, subsidies, where you can purchase, how you can purchase, what you can purchase. So those information are available. Few references which we have used and some publications with respect to this presentation. So any clarity, I have covered the overall information. It is not possible to understand 1 hour or 2 hours. It will take many hours you need to see. I just show what are the research areas, how you can apply where you can apply the AI, and how you can execute the experimentation, those information only I can. Any discussion you please.
Along with the student, you said there was a battery fire, not an issue in conductor experiment with the
While balancing.
while balancing, which is basically a BMS which must at least full time your thermal runaway issue because you monitor your temperature, current and voltage. Did you make any root cause analysis for it? What was the reason?
Yes, correct. See, I said that when I am starting the presentation with respect to the battery management system. The battery management system indicates with not only self-balancing, not only the SOC estimation, not only the SOH estimation, not only the temperature monitoring. So if you are if you are doing all the things only, the BMS it will be effective. So his concentration is only on the self-balancing. Remaining parameters also is sensing, but its sensing mechanism is not effective. That's why he faced that.
Was it from the fixed side or from the distributed side? The battery?
Fixed side.
It is from the fixed side.
Fixed side. It is from the fixed side.
But the battery loading would be higher only in the distributed side.
Yeah, battery loading it will be in the higher side. Maybe the root cause we identified that in the temperature. The monitoring of the temperature he lost. So, but while definitely care must be taken while operating the machine.
Was there any variation in state of health of the battery in the fixed side? Or did he make any preliminary works on battery state of health, aging or degradation part on the fixed side before?
Those things we have not verified. Aging and all we have not verified. Under the charging case alone, we have verified the capacity utilization of the battery.
Sir, how to overcome the SOH imbalance using AI?
What?
How to overcome the SOH imbalance using AI?
SOC imbalance.
SOH imbalance.
SOH
Imbalance.
basically it is a prediction. Based on the prediction only you need to apply, you need to utilize the battery properly. So in this regard you need to train the data properly. Based on the training only you will get the, you can predict the accurate estimation of the SOH. Then the lifetime, how it will be improved, that you can.
So using GNN and RNN using
Anything you can, it will be possible. But the only thing is, morning also I discussed with your HOD, when you are commercializing only the problem. When you are doing the research, it is not a problem, any technique you use.
So, but for AI, whether we are using real-time data is possible.
Yes, possible. You access the wagon, that website is there, no? In that a few data are available. Or Niti Aayog also some data are available. But we are collecting the data is a little task only. One of my student is working as a scientist in Harbor, Chennai, Kamaraj Port. He actually from Hyundai, they manufacture the car. They want to export the car. So while exporting, again they found that the charge level of the battery is getting reduced. They implemented one separate charge. So for that they want to apply some AI.
So compared to government filter method, A is reliable.
We can say that it is reliable, but only thing is, in real-time applications, how you are applying. Research point of view, correct. Research point of view, I can agree. But when you are going with the commercialization, but at the same time, you need to convince. I told you one of our research, like we don't have the galvanic isolation, we could not have published with IEEE. In fact, he tried 2 years to publish in IEEE. But at the end also, one particular reviewer, he did not accept our work. Like he is telling that it requires the isolation. After that only we found then that standard, one particular standard. So we quoted that particular standard and we got publication in Elsevier.
So how can we incorporate sensor noise in AI method? Practically, we can identify the sensor noise, but in AI, how can we?
Actually, basically it is a prediction. You want to reduce the sensor noise, correct? You want to reduce the sensor. Proper measure has to be taken based on the continuous data record.
During the thermal abuse, which you are saying, what is the voltage of the battery for use? What type of battery can you use for the fixed?
See, we tested with the 5 volt level. 5 volt only we tested. So, but when you are looking with the real-time applications, high voltage batteries also. But you can see that I said that our the capacity of the battery is this much size, 1 ampere hour, like a pen torch. So it looks to be this much size. But if fumes are spreaded in entire room, this much size. But if large size batteries and all, definitely we have to take care while operating. But we got a good experience.
Nowadays, many e-vehicles are coming with super capacity.
Yes.
Along with this battery. So battery they are replacing super capacity, which is
Not replacing the super capacitor.
along with this.
Along with the battery, they are operating the super capacitor.
How it will be more advantageous?
See, under the loading conditions, the variation in the loading conditions, sudden change in the loading conditions. So the battery will not provide the, it will not provide the immediate operation of the machine. Under that case, the supercapacitor will suffer.
More questions. We are talking about green energy. Well, that's what they are going to be electric vehicle. But what they are saying in future after 10 years back, more batteries will be a wastage. How to replace it, how to overcome this without affecting anything but as
Good question. Actually, in fact, I have the same thing. See, we need to see that how to reuse those materials. In fact, very recently, MIT, Ministry of Electronics and Information Technology, they called for expression of interest. How to reuse the solar PV panels, how to reuse the batteries. So, how to extract the materials, the useful materials from the battery. How to extract the materials from the solar. So, people are offering many suggestions, but in fact, I am not working in that area. But many methods already they brought it, but commercialization will be the problem. In fact, many they are working along with the AI. Along with AI. Many publications also available, but I could not see in commercialization. But the percentage of the extraction in the paper and all, they are telling that very, very small percentage. But getting the small percentage, they have to invest more. This is only the government question. Government is asking, you are projecting this technology, but for implementing this technology, you are spending crores of crores. This is only the so again, it will balance. After some time, it will balance. Definitely, that side also people are working. Again, how to reuse. So anything else? I just shared my experience, whatever I learned from my PhD scholar, my MTech scholar, my BTech scholar. Mostly I used to learn many things from my BTech scholar only. They used, they are only good in mathematics. So particularly, if I am telling anything, immediately they will write some mathematics. So this is my experience. But MTech scholar, they will work. They are good at a little with the mathematics, little with the experimentation. But a PhD scholar is forced to work. Possible. Wireless power transfer is also possible. Possible. இங்கே ஒரு transmitter coil, இங்கே ஒரு receiver coil. இல்ல இது same transmitter coil, it will work as a receiver coil in another vehicle. But you need to configure properly. So நீங்க என்ன கேக்குறீங்கன்னா பவர் இங்க ரெண்டு காயில், இந்த ரெண்டு காயில் வந்து இங்க இருந்து எப்படி பவர் ட்ரான்ஸ்ஃபர் ஆகுது, இங்க இருந்து எப்படி பவர் ட்ரான்ஸ்ஃபர் பாசிபிள் பாசிபிள். அதுக்கு நீங்க அதை வந்து ப்ராப்பரா கிரியேட் பண்ணணும், அந்த இடத்துல கண்ட்ரோலை கிரியேட் பண்ணணும். See, if it is a AC system, அதுதான் synchronous machine theory. If it is a synchronous machine theory, the first one is a V, second side is E. E into V divided by X into sin delta. This is what the power flow equation. When the delta is changing, the power it is changing. When delta is 90 degree, the power is maximum. This is what we are understanding. But with respect to the power electronic applications, both are non-sinusoid. Sinusoid கிடையாது. So அந்த நேரத்துல தான் you need to apply the phase shifting. So properly the phase shifting controller, then only it is possible power transfer from this side to this side or this side to this side. Many literatures are available with respect to the phase shifting controllers. If you are typing in the ChatGPT itself, you will get lot of it. Only thing is, if you are fundamental, you can validate those. Immediately some information is required. Nowadays we also started to use AIs. But many times we are getting with the false information. See, very recently what happened, one MTech scholar, he has submitted the thesis, a first case thesis, last week only. He made a literature survey with tabulation. Very long, quite long period we are following one author from ATAL. He is working in the machines. Actually, the particular paper with a different author came. So, paper is from IIT Kanpur, but authors are different. The another literature refers that author is IIT Kanpur, but the publication is the others publication. So, mostly it is coming with the wrong information. We needed to justify. For some immediate reference, we can refer, that may not be. But after some time, we will addict. Be forced to use. Thank you for your cooperation. I will share all the fundamentals. Here, one or two work, it is not yet to be copied. That alone I will cut and remaining I will complete. Thank you everyone.
Now, our HOD sir will honor our guest with a gift and a certificate. This session is intended to critically examine the selected research article and to encourage analytical thinking, interpretation, and constructive academic dialogue among the participants. The article chosen for discussion is titled Artificial Intelligence Approaches for Advanced Battery Management System in Electric Vehicle Applications, a statistical analysis towards future research opportunities. This paper provides a comprehensive overview of how artificial intelligence techniques are being applied to enhance battery management systems in electric vehicles with emphasis on performance optimization, safety, reliability, and future research directions. For an effective and focused discussion, the participants have already been divided into teams, and specific aspects of the article have been allotted to each group in advance.
Very happy.
So, now I request the participants to kindly discuss the article ammonia and emails. To begin the discussion, I invite a representative from each team to share their key takeaways and critical observations from the article. Thank you.
Real time support பண்ணாதீங்க.
To begin the discussion, I invite a representative from each team to share their key takeaways and critical observations from the article.
So good afternoon. So because of this is a very lengthy paper, review paper of nearly 50 pages. Okay, so from the abstract and the conclusion and first we gone through all the pages. This is my conclusion. This is my understanding, sir. I may be wrong. As I said already, I am not from a theoretical background, mechanical professor. Okay, so the authors they have carried out the analysis of the statistical evaluation of PMS incorporating AA methods. Then they have studied 78 relevant publications on PMS so between the years 2014 and 2023. So this study will provide guidelines and suggestions for potential research collaboration. So they have grouped key findings in terms of scope of analysis, comprehensive examinations, in-depth coverage of the various literatures, guidelines for collaborations, evaluation tool, contribution to policy making, which will support the government and the entire world, support for sustainable PMS management. Thank you, sir.
Thank you, sir, for sharing your valuable insights. Now I request the next participant to come and share your valuable thoughts.
Dr. Law. I'm Dr. Sindhu Kumar. And this paper was dealing with artificial intelligence, how it is aiding the battery management system. And the statistical data what they have provided, using a different AI tool, they have reached that state of charging estimation error has been reduced to less or minus 1 to 2%, and the overall efficiency has been increased to 95%. In fault detection has been improved to 95%. Thank
Good afternoon, everybody. I'm Kalevani from Rajesh Institute of Technology, and this is a review paper according to the artificial intelligence approach for improving the battery management system. So here they have compared articles from 2014 to 23. It's a recent, till recent studies they have done. Even though from papers which journal they have to they have taken the papers. Including that also they have covered in this particular very rare authors only they will do this survey. So they have done. And the screening techniques. So what are the different screening techniques and what are the different design technologies and what are the key aspects they have to concentrate while designing a BMS system. So all those things are being covered, and advantages and disadvantages, while what is the key area we have to concentrate. So everything has been detailed given in this particular article. So if we are really doing research in this particular area, it's a wonderful paper to review. Thank you.
Actually, I also gone through this article. Actually, here we are given the various approaches which is used for battery management system in EV applications. All the approaches extensively they are analyzed with respect to the literatures. This is only the report says with respect to this paper. Particularly the statistical analysis towards the future research opportunities also. One important thing which I observed is with respect to this paper is in addition to the analysis, comprehensive examination, depth of coverage of the literature, some collaboration. So guidelines for collaboration, statistical analysis, how you are going to have, how you can have a global research collaboration. With respect to that aspects also in this article it is given. So you can collaboration among the academicians, researchers, engineers in the with respect to the BMS area, and evaluation tool for influential papers also it is given. And now one more important thing I just want to say that the contribution to the policy. So that also discussed, you just go through. Then the support for sustainable BMS management, that is anticipated support for sustainable battery management systems in EVs. So leading to extend the battery life cycles, improved EV performance, and alignment with the SDGs. So related to the clean energy, employment opportunities, sustainable cities, and the emission reduction, those informations also outlined in this part. So in conclusion, the statistical examination is anticipated to support the sustainable management in BMS for electric vehicle applications. So therefore, the future research into the advanced BMS will extend the battery life cycles and yes, enhance the EV performance, paving the way for achievement of SDGs for SDG 7, clean energy, SDG 8, and then the employment opportunities and the economic development SDG 11, then sustainable cities, like SDG 30, and the emission reductions. All the informations are surveyed in this one. So this is my observation. Maybe you can use this article for literature studies. Thank you.
Thank you to all the participants for sharing your thoughts and valuable points. Now, I kindly request all the participants to take a break for lunch and reassemble by 2 p.m. Thank you.